Hey, this is OXDF. Today we're looking at Advent of Code 2016, part of the revival of Code 2023. We're doing day 13, a maze of twisty little cubicles. All right, let's jump in and look at the problem. Let's see. Basically, there's a coordinate space that starts at 0, and extends infinitely towards positive x and y, and negative values are invalid. So we have like an infinite in two directions. We are in a small waiting area at 1, 1. And then there's this formula for how you figure out if there's a wall, if there's a wall in a certain spot or not. And so you basically take the x position, you fill out this formula, you add in your puzzle input, which in the sample is going to be 10 off some different puzzle input. Then you convert it to binary, count the number of ones, and if it's even, it's open. If it's odd, it's a wall. Cool. So for the number 10, the coordinates look like this, at least for the first 6 y's and 10 or 7 y's and 10 x's, right? Now they want to know how many steps it takes to reach 7, 4 for the puzzle, and the answer is 11, or for the example. For my puzzle, they want to know how many steps it would take to reach 31, 39 with my puzzle input. So this feels similar to the BFS breadth search that I did a couple days ago. I'll put a video link up here, but seems easier. Let's check it out. So I'll use my genday script here for day 13, and this is going to give me some stub Python scripts to work with, as well as an input.text to look at. In this case, not very interesting. Let's go ahead, and the first thing I'm going to want to do is I'm going to want a function. I'm going to come over here. We're going to try it this way. I'm going to create a function up here. I'm going to call it def is, or like they can move here, takes x, y, and I'm gonna call it like a salt, and we'll just say pass for now because we want to do test-driven development. But basically, if I give it x, y, and what my input is, will tell me whether there's a spot or not. So let's come back up here to test, and now we can write some tests. We're probably not going to need to create file tests in this one. So we'll say def test, I already forget what I called it. Test can move here. Can move, I like 2 better. We're going to change that. Can move 2. That's actually, sorry, I'm going to be really, now I'm being silly, but is valid space. We have test is valid space. And with PyTest, as long as it starts the test, it doesn't matter what I call it, but it's good to like include what you're testing in there. So there's a couple things I want to take advantage. First of all, negative x's and y's are not allowed. So we'll say if, let's see, we're going to need, I guess before we dive in here, we should, why am I, nope, I'm not writing this. I'm going back to test. We're testing. So we're going to do assert aoc.is valid space of, and we'll need like some position and the salt, and we're going to say equals expected. And I'm going to do a bunch of these, so I'm actually going to parameterize it. So we'll say at pytest.mark.parameterize, and then we'll pass it like position, salt, expected. And then we give it this, and we say, so for example, if we want to say like 0, 0, the salt will be 10, and then we need to go consult is 0, 0 open. 0, 0 is a valid space. So this will be true. We then could test like, what about -1, 0? Doesn't really matter what our salt is here, but this should return false. We could do, just for like completeness, we could do 5, -5, and false. Let's get some false calculation one too. So let's see, what's a spot in here that's negative. So right here we'll have 5, 2 should return false. 5, 2, 10 false. And the reason I'm putting 10 for all of these is just because I don't know any other salts to play with. So we'll go with that. So now we can pass into valid space. What did I say for this? X, Y, and salt. So we'll say star position, which will expand position into those X and Y spots. We need to put it here. Position, salt, expected. Star position salt equals expected. Expected. Boom. Okay. So that's actually our test. That's a very simple test. It's only one line, but we're just going to basically test all these points. Oops, I managed to, let's see. So we come in here, I'm going to run PyTest. Cool. I had a different video showing how to set up different configurations so you can actually run PyTest through VS Code like I just did with debugging. Hit F5, and we got 4 failed, which is exactly what we want, right? So we have all these assert none equals true, assert none equals false, etc. Just what we want because we're not returning anything yet. So now we can come write this. Let's see. First thing we need to do is say if x is less than 0 or y is less than 0, return false. That should right away, we're probably going to end up with a return true down here. Maybe not. No, well, let's just leave that for now. Now if we run the test, 3 of our tests pass. 3 of our tests have negative numbers. Oh, no, but one of them has true, and we passed the first one too, so that was, okay. We're good there. Let's get rid of this. That's not what we want. Now we just need to get the math from the page. Let's see. Where's my... I'm going to just grab this so I have it. Paste in here. So we're going to say num equals, we'll just grab that, x times x plus 3x. That seems good. All seems fine. Now we're going to add the plus equals salt. And I'm calling it salt because that's just like typically an added value in to make a value different. So we get rid of that. Find the binary representation of the sum and count the number of bits. Okay, so the easiest way I always do this is just to use an F string. And now if we put num in here with a B, that tells it to print the binary version. The next thing I want to do is get the number of ones. So I'll do a replace on 0, because binary is going to be all zeros and ones. And I'll just replace that with nothing. And so now the length of that is the number of ones. So I can call this like num ones equals that. And now I just need to know if I can return, I called is valid step. So I'm going to say return num ones mod 2. So right now, if there's an even number, that's going to be a 0. So if I turn this into a bool, there's an even number, it's going to be a false. But I want it to be true, so I'm going to say not. And that should be my function right there. And if I F5 this, we got 4 passing tests. So we are passing successfully. We could probably do some things where we get that puzzle, that map, and like parse it in and check every spot on it. But if we spot checked a few, we can add 1 or 2 more. Let's see. Just make sure we're good here. 9, 6 should be false. 6, 6 should be true. Let's just add those 2 in there. Don't know what's going on there. Okay. So we'll say 9, 6 should be false. 6, 6 should be true. We have 5 this, and we are failing. Let's see. Start true equals, oh, because I didn't change it. It's almost like if you put the wrong input in here, it doesn't test right. So I'm feeling pretty good about this function now. Let's go ahead and we will now start to think about part 1. They want me to do the I can't say it, BFS. We'll go with that. Let's come up here and we'll do another test. This one's gonna be very simple too, but we don't need this. I'm not gonna call it part 1. We're gonna call it BFS. Into that, we don't need to pass anything. Pass one input, so we don't need. So we just need to do, if we just do salt is equal to 10, assert that AOC.BFS, and that is going to, we'll have to think about what that's going to look like, but that is going to equal 11. Our breadth first search is going to need a target spot, and it's going to need the salt. So let's go ahead and say, I don't know, like salt, comma, oh no, salt, comma, target. And we don't need to name it, we need to pass it. So we need to pass salt, comma, and our target here will be, what was it in the thing, 7.4, I think? We'll check that before we go. In fact, I'm just going to do this. No need for the variable. And that is going to equal 11. We can get rid of this. We can F5 this. It's going to complain that BFS doesn't even exist. Let's make sure 7.4 was the right target. 7, 4. Okay. Okay, so now come over here. We definitely don't need a parse function today. Go to you, call you BFS. And you are going to take a salt and the target. And now we're back to the same kind of thing we've been thinking about a couple days ago. So I'm going to use a queue to track my positions that I need to look at. So I'll say D, I'm going to make this just like I did before. We're going to do from collections import deck, and then we will do q equals deck, and we always are going to start at 1, 1. And because I want this to be a, I'm going to track my positions. In fact, I'm going to track, there's my position, and I'm also going to track my number of steps. So my current state is going to be a tuple that is x, y, step. I'm just going to, so I start at 1, 1 with 0 steps taken. I'm also going to want a visited type thing. So we'll call it visited equals set. Again, same here. We just want to we want to put the tuple 1, 1 in there. We visited 1, 1. We don't want to visit 1, 1 again. Now we can say while q x, y, I'm going to say t for like time or steps, is equal to q dot top left. We get the first thing off our queue and put it in there. Now, I guess first we'll do a check. If x comma y equals target, return t. So if we reach our target, return the length. Then we can do for. We're going to need to think about like what are the steps we can take. So we're in the position 1, 1. We can go left, right, up, or down. We cannot move diagonally. So I'm actually going to define just for steps, just so I have it, is equal to, and then I can say like -1 comma 0, 1 comma 0, 0 comma 1. The order is not important and kind of chaotic here, but that'll be fine. So I got my 4 different steps I could take. Now I can say for dx dy in steps. And so now the question is, so I guess the first thing we want to do is say, I guess we'll say xx comma yy equals x plus dx, y plus dy. Now I've got my new xx and xy are my new potential spot. We can say if xx comma yy in visited, we'll continue. We don't need to go there again. Then we can say if, what do we call it? Is valid space. Is valid space. And this takes an x, xx, a y, yy, a salt, which will be we've passed in here, so salt, and returns a bool. So we can say, so if the next space is a valid space, then we're going to q dot append, and the spaces are going to be xx, yy, and t plus 1. So like we could be in xxyy one time later. We'll also do visited dot add. We just want to add xxyy. That works. And I think that's it. It feels, yes, passing the test. That's a good sign. Let's go ahead and make this Python current file. I haven't checked down here. Okay, so we gotta check this. So to solve, I don't need puzzle input at all. I just need to call, BFS on, what is that target? 31, 39. So what is close to the VS? Salt will be puzzle input. In fact, it'll be the int version of a puzzle input. And then we need the target is equal to, I'm going to do this by name just so I have, so it's clear to me what I'm doing. Salt equals that. Target equals 31, comma 39. I believe that is right. Let's just double check. Okay. And then solution 2, we're just going to say is equal to none. We don't have it yet. We don't. I think we're good. Let's see. If we hit F5 here to run this file, we get an answer 86. Over here, 86. Awesome. I'm going to pause this while I read. Maybe not, because this is very short. How many locations, including your starting location, can you reach in at most 50 steps? Okay. So let's refactor this BFS a little bit. we're going to add in part 2 is equal to set 1, 1, things we visited. Then we'll come down here and we'll say, because we know our part 1 is longer than 50 steps, so we still want to return here. We're just going to return part 2 as well. In fact, we're going to return len part 2. Really, we could call this, let's see, let's rename this. Visited in less than 50. That's a long name, but we're going to go with it. So now we're going to return the length of that as well. And then down here we have is a valid space. So if it is a valid space, we'll say if p is less than 50, visited in less, oops, visited in less than 50 dot add xx comma yy. And that seems almost too easy. We better test. There's no real test we can write for part 2 because we don't know any legitimate answers. They don't give us, you know, hey, in this example of 10, the answer is 45. So we kind of just have to, we're going to have to go blind. So we're just going to effectively get rid of not have any tests for part 2. But we can say, we can still run this. Let's see. So we do need to make sure, let's see. We need to make sure this is equal to expected comma like that. Or what do we need to do? We can actually say, let's update this test a little bit to say result comma that equals there. And then we can say result equals expected. Assert. So now if I F5 this and run again, oops, if I switch to PyTest. Whoa. All 7 tests failed. It's probably because I probably have an error in my thing somewhere. Cannot unpack a non-iterable bool object. Where's it? That was my test. What? Let's see, F5. So we can see over here, position is that fine? Position is fine. Position. I'm just watching over here the values of position change. Okay, here. Did I do something? Did I pass in wrong here? Not. That's weird. I'm just checking. I'm just curious. Is it just this function that's bad? Let's see. F5 here again. Let's take this breakpoint out and see if we're still failing. No, we're all failing. Test is space valid. Is valid space takes position. I don't know why this would have stopped working. This is interesting. I mean, that's kind of why you do tests, because if I could have really broken something. Oh, wait, is valid space doesn't return. Let's undo all that. I'm being really silly there. So I don't know why I broke that. Invalid space returns a Boolean, like it didn't matter. Okay, so we've got one failure. Sweet. Assert 1120 equals 11. Of course, because we need to do now here is where I need to make that change. We'll say result, comma, don't care about part 2, equals that. Assert result equals 11. Save F5. Sorry for that trouble. We've now passed the test. I mean, this is all like, I was just tinkering and I probably had the answer already. Let's check it out. Part 1. Oh, okay, so let's see. We should make this pretty. Solution 1, comma, solution 2. Get rid of that. Save, run again. Solution 2 equals 127. Again, we had this a while ago. I'm sorry, I feel like I wasted your time, but hopefully you enjoyed watching me debug. Anyway, this challenge was not too hard. Thanks for hanging out with me today, and I'll talk to you tomorrow. Bye.